Hi, my name is Savannah Rice, and this is my agricultural buffer strips presentation for the My Favorite BMP project. So, starting off with what agricultural buffer strips are, they are basically strips of planted vegetation, including shrubs, trees, planted legumes, or any other type of vegetation that can stop phosphorus and nitrogen runoff from fields. So these are planted on the edges of fields right next to waterways, or as we'll talk about later, how they're on different contour planes, and basically anything to keep surface water from being contaminated. So many of the benefits is that it filters sediment, stops the runoff from the fields, and prevents soil erosion. And we'll talk about how later it also helps with wildlife habitats and increasing biodiversity. Basically, this is just stopping the nitrogen and phosphorus from getting into the surface water and thus contaminating it and causing eutrophication, which is very harmful to aquatic life. So some of the variations within agricultural buffer systems includes contour, which is basically where it is planted vegetation in strips of contoured planes on the field. So it's alternating with crop strips already established, whether that's whatever crop they're using or just till the plan. So essentially, it keeps that soil from being run off, and as any of the water or fertilizer is coming off the land, it gets trapped in the vegetation before it makes it to the waterways. This is a great option for orchards and vineyards as they have many different sloping planes within their fields, so this is a great way to keep fertilizer from running off into those. Another one is riparian. This is a mix of trees, shrubs, whatever other vegetation you want to use. Pretty much the most common one. They also are really great for helping with wildlife habitats. With this, because of the many different types of vegetation that you're using, it creates a nice little ecosystem for any different kind of wildlife that would be present next to those waterways. And additionally, because they use trees and whatnot, it helps with temperature regulation on the outlines of those waterways and thus controlling the temperature just a little bit inside of the waterways, which is really great for the aquatic life present. And with also this, because of the different types of vegetation used, as I mentioned previously, this also helps with flood prevention, which is a really great useful tool when any flooding happens within those waterways and it doesn't get back into the field. So a little bit more economically friendly for our farmers. And the last one would be harvestable, which is where this is vegetation that is periodically harvested for forage. So it also adds a little bit of money going back to our farmers. As I said, it helps economically, and these are most likely around field edges, so they're still able to be harvested, but they do act as that buffer, which is really great. And because of this, there's very low maintenance, so farmers can choose how they're flexible with their schedule based on when they want to harvest this or take care of it, as it is completely up to them. So here I just put some pictures in just to show you. So around here is the contour, as I showed you, with the alternating strips with the planted vegetation. And then you also have some vegetative buffers right here. So there's two different kinds showed. And then the newly cultivated part, which is the up-tilled soil that has not yet been filled in with crops. So that just kind of shows you a little bit of how that would look on a more contoured plane rather than just a flat field. And then this little depiction shows you how many benefits come into here. So as that would be more of a riparian buffer strip, but as you see, it's removing those nutrients from the agricultural activities, and then all of those things go into protecting the biodiversity and the wildlife present within those ecosystems next to the waterways and within the actual water body. So that's really, really helpful. So some challenges that we do see with agricultural buffer systems is that it can be very costly to maintain. So we'll talk more about cost later. However, it's around $200 to $2,000 to maintain per acre, which can be very costly to our farmers. And with this, it's ongoing management. So you always have to take care of it, otherwise it's not going to be as effective. And in addition, there's also a lot of regulations on these practices, whether from state, federal, local laws, or the EPA, or any other different kind of programs that are overseeing these practices as they're put in. It also can be a little challenging to measure your effectiveness of these practices. There are several methods that you can use. However, there's not something that's completely accurate. So it's really more about just cost analysis, making sure that whatever you're getting back or you're maintaining with environmental benefits benefits, equals out to what you're also paying. And another challenge that we do see that happens sometimes is because of the planted vegetation and the already established root systems in the soil, sometimes invasive pests and plants can come into those little ecosystems that are made and kind of overtake those places just because it's all one vegetation, or if it's very new and not really readily established yet, so that can be a problem. So ways to measure the effectiveness within this is sediment trapping, and you also can look at the nutrient reduction, and then you can also measure soil moisture levels as well as water infiltration. And then some statistics that I have for you that kind of show this is that sediment reduction with buffer strips can be reduced by 50 to 90% depending on the type of vegetation that you use and the width of the buffer. And then also with nutrient runoff and reduction, they can reduce nitrogen and phosphorus by 40 to 80%, which is significant. And also with pesticide reduction, 50 to 75%. So you see the statistics are super helpful in seeing that these are actually a practice that is really, really beneficial and something that should be implemented to help out with environmental impacts. So the cost, as I was mentioning previously, can range from $200 to $2,000 per acre, with opportunity cost, which is basically the money that's deducted from the value of the land. That would be $50 to $500, so that makes the cost a little bit less. Maintenance, mowing, and all of those things can cost you from $50 to $200 per dollar or dollars per acre, just depending on what kind of buffer strip you're using or the vegetation or other things that you put in place. And then there are some programs such as CRP, UKIP, QUIP, state and local programs that do help out with the cost of this. So for CRP, this actually can take up 90% of the cost for establishing the practice, and then in a 50% cost share payment and a 40% practice incentive payment. So that's really helpful with covering the cost of these practices that need to be implemented. And these are my sources. I use the Conservation Buffers Center for Regenerative Agriculture and the Contour Buffer Strips Natural Resources and the Buffers and Vegetative Filter Strips. So these are the resources I used for those slides.